scamming has always been part of the American scene.
There's no question scams are becoming more and more sophisticated, and cybersecurity experts are warning artificial intelligence in the hands of criminals is becoming a game changer.
The dark side of artificial intelligence to generate this entirely fake e-commerce site in about 7 minutes at a cost of about $8.
Finance worker in Hong Kong who was duped into handing over millions of dollars after being tricked by deepfake technology during a conference call. It's the latest frightening example of how quickly artificial intelligence is progressing.
$25,000 is now out of my wife and my retirement savings.
The very new twist, crooks using artificial intelligence to rip people off.
Now they're taking advantage of AI to make their scams even more believable.
If I was interested in investing in scamming, it's going to be the growth industry of all time, and it's innate.
Well, for those of you who know me really, really well, Warren Buffett is one of my biggest heroes. So when he talks, I really listen. So I was really shocked by his comment when someone asked him about his view on generative AI. But at the same time, I do totally agree with him that AI will make the fraud industry the fastest growing industry at all time. That's why at GoodLabs, our dedicated PhD postdoc research team, we strongly believe that the only way to tackle this is do exactly the same, which is using AI. Now, it's not just any AI, but streaming AI to shorten the detection time and defense response time dramatically. Now, today, I'm honored to join some of the industry heavyweight in the space to discuss and showcase how we can apply streaming AI to assist fraud fighting teams in tackling ever-increasing threats from fraudsters equipped with advanced technology. Now, let me introduce some of our guest speakers and our partners first. First, Adam Cohen, AVP Product Group Technology Lead, Event Streaming, AI Management from TD Bank. Adam? Rochelle Grubbs, Senior Director, Solution Architect from Mainframe Expert Precisely. Rochelle? Sam Murana, Senior Sales Engineer from Streaming Data Platform, Confluent. And then Michael Moore, Senior Director, Strategy and Innovation from Graph Analytics Leader, Neo4j. Now, let me just do a quick go around first to see what everybody thinks how important streaming AI is in fraud defense. Adam?
Sure. Thank you so much, Thomas, for inviting TD to join you today. We believe at TD Bank that real-time data products are going to become a foundational component for the future. The ability to publish and react to business outcomes in near real time. It's a foundation just like it was a decade ago of APIs. Being the forefront of your technology landscape, we believe strongly that real-time data products are going to provide that next generation that allows us to tap into things like AI, data at the edge, and other really important capabilities.
Well, thanks, Adam. Rochelle?
Thanks, Thomas. So real-time access to data is critical for all sorts of applications, and Precisely is very invested in helping customers access real-time data from all sorts of platforms, whether they're legacy platforms, not legacy platforms, recognizing the need to access data from across your enterprise and just how critical it is to support all sorts of business use cases.
Thanks, Rochelle. Sam?
Yeah, real time is definitely at the forefront of combating fraud. I think last year's event, when you demoed the account takeover, there was a number that stuck with me, Thomas, and that was 5 minutes. It takes 5 minutes for an account takeover to happen. So the closer you get to the source of the data, the source of the issue, the better chance you have to react to it.
So Sam just ruined the surprise. We are doing ATO, but an extension of the ATO today. Michael?
Yeah, the way that we look at it is you absolutely have to be able to detect changes in patterns in real time. And so Neo4j's graph database allows you to unify and mobilize a huge amount of data from multiple sources, including sources like Confluent. And then once you have that raw stream, to be able to put it into some kind of a context where you can say, just in the last update cycle, we've seen new patterns, new connections, maybe new IP addresses, new synthetic identities, new transfers of funds that are all highly unusual and could be indicative of collusion and fraud. And your ability to react to that quickly, recognize those patterns, and react to it quickly is critically important.
Oh, thank you. This is obviously a very, very critical moment right now. How are we able to extract data in near real time and apply the right tool to be able to generate the right insight for any type of business use case and stuff? So now, can we swap the screen to our demo? So the demo we have today is the, like what Sam mentioned before, it's an extension of the account takeover scenario we showcased last year. Now, ATO continued to be a very, very serious problem, causing a huge amount of financial damage to banks and the customers. Just in 2023, it caused like $13 billion in damage, with over 354% year-over-year increase. And as fraud fighters, we all know it, detecting ATO from the bank system is not an easy job. We have to analyze customers' behavior to determine if there's any anomaly in place. And the detection, as Sam reminded me last time, it has to be within 5 minutes, because typically that's how fast the bad actor will go in and out with the financial gain. So now, make the matter worse, you want to make sure that you do identify these suspicious activities correctly. Otherwise, you will have some very, very unhappy customers. Them you do, and them you don't. Now, let's quickly walk through our demo setup today to understand how the ATO is performed. What you see on the screen is our simulated online banking platform, which we use it for our financial crime engineering testing. And it was developed to match very, very closely with what most of the banks have. Now, let's also take a look at our financial crime control center, which also simulate how a bank fraud detection system works. What you see on the screen is our simulated financial crime control center showing the current active online banking session. Now, the bad actor will typically invest in black SEO, roughly around 3 months time frame, to game the Google search engine to rank the fake banking URL, which looks very, very closely to the real banking URL, higher than the real banking URL, to target the victims who, just like me, typically type Google their online banking URL instead of specifically type it in. Then, once the victim clicks on the fake banking URL, it will redirect them to the variants of the evil proxy, which sits between the victim and the real banking site, and trap all the login information alongside with two-factor authentication to access the victim's bank account totally. Now, the victim will Google the bank URL. The black SEO worked extremely well, positioned the fake banking URL at the top. When the victim clicks on the link, it goes right directly into the evil proxy. Now you can't really see it, but if you look closely at the URL, it looks exactly like the real URL, but has a little bit variation. Now user will type in the user ID password alongside with the 2FA token. So all the information has been captured in the evil proxy, as you can see on the screen, including the 2FA. And the evil proxy will relay the information back to the banking system. The evil proxy also captured the victim's session ID token. Then the bad actor can paste the token to take over the victim's account. It's that easy. And there you go, we're in. Now, the bad actor can start transferring funds to fulfill the financial gain objective. And these take place in under just 5 minutes. And the bad actor doesn't even need your password. As mentioned last year, one effective way to detect ATO is using what they call the traveling speed. As we can see in our control center, there's a red alert to indicate there's a suspicious account activity linking 2 sessions together and triggered by the traveling speed. Now, the theory behind this is typically when you're accessing the online banking, unless you're using VPN, it's very, very unlikely the geographical locations of the source IP address will change so drastically with such a big distance discrepancy that will trigger the alert based on traveling speed. Now, we are able to quickly analyze the traveling speed and the distance thanks to Confluent's real-time streaming data platform, which the top 17 financial institutions use it to analyze and trigger the alert as quickly as possible. Now, Adam, does the streaming data platform play any role in your organization, and what type of use cases are best suited for the streaming data platform?
Yes, Confluent Cloud and Confluent Platform play critical roles at TD Bank in exchanging real-time data across our firm. We use it for use cases such as data at the edge, feeding real-time analytics engines for fraud, as well as other use cases around data movement that create new customer experience as well. You can use it just for fraud, you can use it for anything. Once you put that data on the pipe, it can be reused again and again and again because of Kafka's native persistence. It's really a powerful use case, and you can attach it to any number of outcomes.
Thanks, Adam. And Sam, could you tell us a little bit more how you see your customers are using Confluent in such an urgent scenario in fraud detection?
Yeah, absolutely. So our customers are using Confluent and the rich ecosystem of connectors to bring in data from multiple different disparate systems and generating new outcomes. So they can marry data from a mainframe, from a database, from even external websites. And we also see them, making, once the data is in Confluent, you can aggregate and merge it, but they'll make third-party API calls to people that specialize in fraud and get a result back to generate yet another outcome.
Great enabler. Now, we know that the bad actors will not just invest 3 months in black SEO for a one-time few $1,000 gain, okay? If we assume this is truly a fraudulent activity, we must act quickly and find out if we also have other victims. One effective way to do this is to use graph analytics. Now, if we use the suspicious device ID and the IP address, most of the unsophisticated bad actors would use a device farm with a single network to attack many victims because they're lazy. Now let's take a look at what we can find from the suspicious device ID first. Look at that. That is deep. Based on the current access, the suspicious device is linked to additional IP addresses with many more accounts affected. So now we are at the stage that we can definitely confirm that this is a bad actor. Now, let's take a look at the originating IP address. Whoa, same observation. The damage runs very, very deep. Now, Michael, from what you see from your customers, how do they use the graph analytics tool in fraud prevention?
So this slide here is a great example of how by taking discrete transactions, say between 2 points, and putting them into graph context, there is an immediate pattern of activity that emerges that's highly unusual. And so, for example, like even if you were on the banking side and you said, I want to see how many new wire transfer recipients have been generated in the last 24 hours, right? You put that into graph context, you put that up against an IP address, you can immediately see these patterns. And so our customers use graph analytics for doing things like detecting auto fraud rings where there's a number of players that are colluding. They use it to harden their cybersecurity surface area, looking at authorizations and accesses. They use it to understand customer experience. So, for example, that flow that you just showed, there was no interception or additional validation around creation of that new account, right? And there should have been a phone call, right? Absolutely. Or something, right? Yeah. And so again, customer journey, being able to understand deficiencies in the actual experience. And then finally doing things like money laundering, identifying bad actors, pulling together interesting tidbits that are coming from various media, like social media, right, where somebody's celebrating their gains. All of these kinds of things are being used to understand the activities of fraudsters and be able to quickly shut them down.
Thank you, Michael. And Adam, now, what we have done so far is actually looking at the different sources of data from different angles. Now, how important is it to look at different sources of data from different line of business from different angle in the data analytic world in your organization?
It's incredibly important. Large organizations like TD have a legacy footprint where data lives on a mainframe. It's been historically very difficult to get that data off in real time, to unlock some of these next generation capabilities, Neo4j, Confluent Cloud, and others. Working with teams like Precisely, we can harvest those business and those data changes in near real time. By that, it's milliseconds, and get them available to these next generation of services. Historically, we triage this in batch, measured in hours or days. That no longer meets the market's expectation or a customer's expectation. You need to put your data and your data products on a real-time pipe to truly unlock those sort of services and experiences customers need. You don't cross, Bay Street in front of us using yesterday's signal data. Otherwise, you're going to be pancaked. You need to look at it in real time. These signals and these events happen in real time. Fraud happens in real time.
Real time, so important, but it's not easy. That is the challenge. Now, it looks like we got another alert of traveling speed violation. And in this one, it's a lot more complicated. It's across the continent. So what's going on? Now, let's use the same formula and see whether we can discover what's going on. Let's do the same thing on using graph analytics. Looks pretty legit to me, right? Single device, single customer, looks okay. So what's really going on behind the scene? Because now the graph analytics doesn't really reveal anything. What do? Do we treat it as a suspicious activity and risk creating customer friction and ultimately unhappy customers? Now, like what we do, let's take a different approach to confirm. On our side, in the simulated platform, we have built a real-time customer persona database utilizing individual behavior, including geolocation, IP address, device, access time, authentication. Very, very multi-angle. We would then use the individual personality trait and apply classical machine learning model to determine the anomaly. Then we'll combine multiple behaviors to confirm the anomaly itself. This is the perfect use case to apply streaming AI, since the human fraud team won't be able to keep track of each customer's personality and determine the anomalies. And streaming AI can scale very, very well on that front. Now, Adam, we all know that it's quite useful to build a real-time customer persona database, not just for fraud prevention and in a financial institution. What other line of business do you think that would be benefiting from it? And what challenge do you see to getting the streaming AI to produce the streaming insight?
So we see a lot of use cases around using streaming to get data at the edge, to unlock new types of experiences and outcomes and reduce latencies for our customers. When it comes to real-time analytics and those streaming database scenarios, we believe streaming into complex ETL platforms like a Databricks or Node4j and others really can unlock that next generation of visualizations that allow us to see data in different ways. Structured data is complex to see normally. When you start to layer that complexity on with different dimensions, that's where Neo4j and actually Graph is really powerful at. You can really start to explore your data and identify patterns that are impossible to see otherwise.
Thanks, Adam. And Rochelle, you look very lonely and quiet over there. Maybe I'll throw you a complex one.
Okay, sure.
So if we're going to build such a customer persona database, what information do you think would be the most useful as the basis of such database?
That's got to be credit card information.
Credit card transactions. Okay, that sounds very juicy. Why would credit card transactions be useful?
Well, think about it. You use your credit card today more than ever. I don't know about you, but I probably have $10 in my wallet.
Uh-oh, I can't rob you anymore.
But I have my credit card. Yeah, so if you steal my purse, but you'll have my credit card. And credit card transactions give us a lot of information about patterns, good patterns as well as bad patterns. You can see geographic patterns, demographic patterns. I might shop at particular stores or eat at different style restaurants, and if suddenly those patterns change, then that's a big red flag for the credit card processors.
That is so true, Rochelle, because just like you, I probably have more than $10, but I use my credit card heavily, particularly Apple Pay and stuff. Now, how do we get such a credit card transactions in real time then?
Well, you have to use change data capture technology. So using technology that captures changes directly from the source system, reading the changes not from the application itself, which is going to take too long, but from the application logs. So as and when each transaction happens, it's read and pushed to platforms like Confluent that stream the data, and you have access to the data in milliseconds, not seconds, but milliseconds. And then you can use that data for all sorts of use cases, analytics use cases to support additional applications, fraud, money laundering, all sorts of applications, good and bad, where seconds matter.
Yeah, absolutely. And since we're all mostly bankers here, everybody wouldn't be surprised to know that most of the credit card transactions live inside the mainframe system because it's rock solid. So that's why we built a real-time mainframe data extraction from a DP2 instance credit card transaction table, just like the one that you see from TSYS, which manage most of the financial institutions' mainframe transaction. And we actually use precisely CDC Connect with our custom-built Confluent integration to be able to send encrypted change data capture, like what Rochelle mentioned, from the mainframe to Confluent Cloud in real time and then perform modern analytic, including using the like of streaming AI in Flink. Now, before we see this in action, Sam, from what you have seen your customer, how do they use the like of Precisely and other technology to stream database transaction to Confluent Cloud for real-time analytics? And what benefit are they seeing? And what upcoming technologies is Confluent building to enable advanced technology and analytics like streaming AI?
Definitely. So Rochelle's mentioned change data capture. This is a mature implementation. We all know the golden gates of the world. Doing CDC off a database like Oracle or SQL Server is nothing new. However, getting access to a traditionally untapped resource of data, the mainframe, is a hot topic these days. I can't tell you how many times on calls with customers we're talking about mainframe modernization, getting access not just to DB2, but vSAM and IMS data. That's like, that's the cat's meow, because traditionally, coming from a file transfer background, I have done file transfer in my past, that data was far removed from you, at least 24 hours. You need to set up a file transfer to get that off the mainframe. So streaming that real time into a Confluent Cloud and then enabling other tools to act against that data is super beneficial to our customers. And in terms of what Confluent, well, today we just announced CP 7.8, shameless plug, which now GA'd Confluent platform Flink, fully supported. But in Confluent Cloud, Flink has been available for quite some time. So that's there. It gives you a SQL API to introspect your data, enables AI and ML capabilities. And coming soon, 2025, is Confluent's implementation of Apache Iceberg. We are going to call it Tableflow, which is going to bridge the gap between operational data and analytical data. Right? It's going to allow you to represent a Kafka topic as an Apache Iceberg table, and then you bring your own compute, whether that be Databricks, whether that be Snowflake, to introspect that data real time.
Did you use the word shameless?
I did.
I'm going to beep that out afterwards. But so, in this real-time customer persona database view, we utilize real-time credit card transaction as our basis to build the customer persona. In this particular view, since we're very, very much focused on the violation of the traveling speed, we will focus on the geolocation of the credit card transaction. Now, we're going to do a little bit on the time machine. Now, on December 7th, the customer had a transaction on a flight purchase. A typical flight purchase, I don't know whether you have seen on your credit card statement or not, the transaction will contain the description on the departure and arrival. Very useful information, but it's very free text. Now, the large language model kicks in the streaming data analytics and extract the departure EWR as Newark and the arrival BCN as Barcelona. Geolocation tolerance will be created immediately by searching all the possible in-flight Wi-Fi ground station with the flight path between EWR and BCN. Now, on the transaction description itself, there's no flight date. So the system will just put a monitoring in place to remove the tolerance when it detects the customer finished the flight based on geolocation analysis. Now, with the real-time credit card transaction, we now know that the customer is at Newark and has just finished a meal at Shake Shack. Don't like that restaurant, but it's okay.
You don't like Shake Shack?
I'm okay.
Ate there a couple weeks ago.
Now, let's talk about Shake Shack afterwards. We have a long discussion. Now, next, the online banking IP geolocation. Now shows Brunswick and Portugal, which is not the typical location of the customer, which is from New York. Now, the two locations pop up at the same online banking session, which triggered the traveling speed violation. Now, without the credit card transaction, this alone will definitely get flagged as suspicious activity and might even create high friction to prevent fraudulent activities. But what happened in this case is the customer, potentially a high-value customer, was using the in-flight Wi-Fi with the flight location and the in-flight Wi-Fi, which could be on the Starlink, jump from Brunswick ground station IP geolocation to Portugal's ground station IP geolocation. Now next, the online banking IP geolocation. Now jump to Barcelona. At the same time, there's an in-flight transaction which shows a credit card present transaction with the IP geolocation showing Lisbon. Now the online session geolocations are much narrower now than before, but still violating the traveling speed. But with the credit card in-flight purchase and previous credit card transaction on flight tickets for geolocation tolerance, this customer persona database provides a much smarter fraud defense system that will not create unnecessary customer friction to annoy customer on performing legitimate transaction. In particular, in this case, it could be a high net worth customer trying to perform a very, very critical banking transaction on the in-flight Wi-Fi. So, very, very important. Now, this is indeed a rare scenario, but it is a rare scenario that can showcase how powerful streaming AI is in the fraud defense world. Although we see tremendous benefit on applying streaming AI, now, I want to ask our speakers tonight what challenges they are seeing organizations to be able to adapt streaming AI and what they can do to overcome the challenge. Maybe I'll go with Adam first.
Sure. I think then once you get your data onto a stream and you create your data products, the next thing is the processing engine for that. And obviously Flink SQL is an incredibly powerful engine to accomplish that, but there's so many tools in the market. That is probably the next challenge TD Bank has to solve is what ETL, real-time analytics tools do we want to unlock? Because it's the legacy market, your Databricks, they work in Spark, they're micro batch. What sort of technology do we want to really truly unlock that real-time streaming analytics, and which partners do we want to work with? That's something that we're focusing on in 25 and beyond.
Lovely. What about Rochelle?
Well, when you think about additional use cases, additional uses of the data, the nice thing is when you have the data in Kafka, you can have additional applications subscribe to that data. So first of all, you don't have to go back and incur any cost or time to go get the data. And then we're seeing use cases, lots of analytics use cases, as well as lots of use cases where we can make offers or better offers to customers. So white space, if you will, where a customer may not know a particular product is available, but based on other patterns, other buying patterns, other information about that data, then they can learn about that type of data.
Have you seen anybody applying AI in the mainframe yet?
Yes.
Wow, okay, that's...
Yes, and actually that's, when you think about, that's a great question because AI and the mainframe, think about just when you say that out loud and you think about the cost to do that, it makes you shudder because mainframe costs are so through the roof. However, imagine having all of your mainframe data accessible to models that you're using, AI models, to power AI use cases and Gen AI use cases.
Absolutely, absolutely. And Sam?
Challenges we're seeing is, just reiterating what we've already talked about. The data has to be clean, it has to be fresh, it has to be trustworthy. So those are challenges. The end-to-end latency of the data. Especially, data coming off the mainframe, it could be like drinking from a fire hose. So how do you ingest that and act on it quickly enough? The infrastructure costs of running AI, ML engines, and the skill sets that are required to run that are challenges. I think part of your question was around, what recommendations we have around these. Well, running these workloads in Confluent Cloud solves a couple of those skill sets. We'll take the operational burden off of you. The infrastructure costs, you only pay for what you use, in the case of CC Flink, which is serverless. So you can offload some of the complexity. The latencies are, as our customers can attest to, sub 10 millisecond, depending on which regions you're running in. So that's some of the stuff we're seeing.
Yeah. And Michael, I mean, Neo4j is just fascinating. I've seen some article even talking about, I don't know whether you guys know or not, but they even actually get into very, very large model, for example, large language model, even actually trying to pinpoint some of these very, very fine-grained area, almost like repairing a brain functionality. That sort of functionality that you guys do, right? So what about you? What's your opinion on this?
So I think if we step back a little bit, this example is really all about understanding these individual transactions in their context. And so we've always recognized the importance of real-time data, real-time streaming. There's a very, very nice Neo4j connector that's available on the Confluent Cloud, where a Neo4j graph database can subscribe directly to Kafka topics that are being managed in Confluent. And when you bring that data into Neo4j, the real challenge there is modeling the data appropriately so that you can reveal the patterns that you're interested in. And then, this is an individual view. So the real question is, how do I do this at scale? How can I look at hundreds of millions of transactions that are occurring in a daily time frame and pick out this pattern and say this pattern is an acceptable pattern versus this is a pattern that violates maybe my travel time, right, in a real way.
Absolutely.
And so one of the things that we do offer in Neo4j, another shameless plug, is that we have an analytics library that allows you to analyze, it's called Graph Data Science, it allows you to actually analyze the entire topology of the graph that you've built. And as you update that graph, you can actually analyze the temporality of how patterns have started to change in that graph. So for example, if somebody dumps a whole batch of credit cards into the market and is trying to do a cash out, all of a sudden you're starting to see a whole lot of transactions, right, associated with a bunch of dormant credit cards. And so being able to quickly see the emergence of that pattern, being able to detect it at scale amongst millions of other legitimate transactions, I think that's a challenge. And then the other part of it is that, of course, this is an arms race. And one of the things that financial institutions fall down on is that they have an over-reliance on rules-based systems like Actimize and NICE and things like that. And you have to think much more in a much more agile fashion, because what's actually happening is every pattern that we can detect and identify and shut down, fraudsters are going to think of something new, and there will be this period of time where they're getting away with it before we can detect it. And so your ability to not only just move data, but be able to spend a lot of time analyzing and seeking out new patterns and discovering new types of fraud, I think that's actually a big challenge. And so hopefully with the kinds of tools and automation and service, sort of service-based architectures that we can provide, it actually allows analysts to spend more time analyzing data and less time moving data around.
Thank you. It seems like on the right-hand side, shameless, it's a theme. Except me. But thank you very much. I hope everyone find this session informative. I want to personally thank our speaker, Adam, Rochelle, Sam, and Michael for providing their invaluable insight. Now we will take another network break for 15 minutes. Please enjoy the refreshment. We'll be back with our closing session amazing visionary roundtable to discuss one of the most important topics in fraud fighting, information sharing. Thank you very much. Thank you. Thank you.